Do not analyze the force that are the cross and the what? And the dot. So don't analyze anything that are cross and dots. So the dot is 200 pounds. Don't analyze it yet. The cross is 150 pounds and another one 50 pounds. Don't analyze that. You only analyze this sort of arrow. Okay? We only analyze this sort of arrow. Right. So the most obvious thing is this. Okay. We know that we are going to have a px that is equal to 150 pounds. So this force over here, right, is parallel to the what? Centroid. So it is also going to induce 150 pounds in the x direction. Okay. Now, this force over here is also going to induce, okay, so first of all, Px is 150 pounds, and on element H and on element K is going to induce a positive, which is what? Tensile. Right? It's pulling it away. Yes or no? So it's inducing a tensile stress. Okay. Then you look at the moment, right? The moment is going to induce is in this direction. Yes? So this is moment in the z direction. Okay? So we look at the perpendicular distance now. This is the perpendicular distance. Okay? So the perpendicular distance is towards the what? The centroid. And that distance we are given as 10 pounds. 10 inch. So therefore, we can calculate mz. So we call mz positive going in a clockwise direction. Okay, this one you decide. You no need to follow the transformation. You decide where you want it to be positive, where you want it to be negative. Okay, so from here, moment about z is equal to 150 multiplied by 10. So 150 multiplied by 10 is 1,500 pound inch. And it's in this direction. So what did I teach you about the moment vector? Can you remember? The head of the moment vector will always be what? Compression. The tail end will always be what? Tensile. Okay? So when the moment is this, you can write this down, right? So you can say that element H is going to have what? Positive is going to be tensile, right? Right, because element H is above the what? The centroid. Above the centroid is going to be what? Tensile. Okay. Whereas element K is going to be equal to 0 because it is at the what? Centroid. Okay. So this is what we call analysis. Okay, this is the analysis part. This is the part where if it's going to go wrong, it's going to go wrong here. But this is an easier way of doing it. Okay, compare of just using vectors alone. Okay. Now, one thing I want to draw to your attention is this. The deformation due to mz is going to deform this way. Right? So this is the deformation pattern. Due to mz. Okay, I want you to start looking at deformation pattern also. All right, from here, can you do anything else? Nothing. right? Why? Because the rule says analyze, do not analyze the dots and the what? And the cross. So if there's nothing more to analyze, move to the next view. Okay, so we're going to do another view. So I'm again going to copy this image. Okay, now I'm going to draw XY view, XY plane. Okay, XZ plane, and then the Y, this is rotation about Y. Okay, and there's something very interesting that's going to go on. Okay, so I'm going to draw the structure now, sketch, not draw. Okay, so this is what we see. Okay, and this is the, okay, right? You can visualize that, right? So then we put in our forces. So we have our 50 pounds over here. We have our 200 pounds. We have our 150. We have our 150 over here. And then we have our element K. And then down here, our element H. Okay. Then we draw our straight line. We draw our centroid relative to element H and K. So this is a 2D view, right? So when this is not so obvious initially, right? Right? PX having a horizontal axial load is not so obvious from the other view. Am I right? From this view, isn't it obvious it's 150 pounds axial load? Yes or no? More obvious now, yes or no? Am I the only like idiot that's excited now or what? You guys are not so exciting at all. Right? Can you all see that now? Isn't it obvious, right? PX is horizontal over here of 150 pounds. Now you see it, yeah, I can see it as 150, yes or no? Right? Over here, the other view is not so obvious. The other view, I use eccentric loading. From this view, it's not so obvious, yes or no? Right? But if you look at the plane view, it is very what? Obvious. Yes? Okay. So now the next one, we are going to calculate the shear stress or the shear force. Okay. So we are going to calculate, I'm going to say that over here, positive is going up. Okay. So we are going to do forces in the Z direction. So going up is positive. Okay. So 150 plus by 50 minus by 200. This is equal to what? 0. Okay, sorry, not FZ, is your VZ. Okay, your VZ is 150 plus by 100 minus by 200 is equal to what? 0. So the shear force in the Z direction is equal to what? 0 for this case. Okay. Then the next one we are going to look at is we are going to look at moment in the y-axis. Okay, so we are going to take moment at point H or point K. Okay, so this is where I draw the cross. This is where we're going to take our element. Okay, or on this line, or on this line, this is where we're going to take our moment. Okay, so now we have to find the perpendicular distance. Okay, so for this case, these are the perpendicular distance. So the distance from here to here to the 200 is equal to 10 inches. Then we have our 6-inch, 4-inch, sorry, I draw it not to scale, my apologies. And then this is our 6-inch. Okay, so I call anything that is rotating in a anti-clockwise direction, moment about y is my positive. Okay, so this is positive 150 multiplied by 4 plus by 50 multiplied by 10 plus by 200, sorry, minus 200 multiplied by 10. So 150 multiplied by 4, 600 plus by 500 minus by 2000. So this is equal to 600 plus by 500 minus by 2000 is equal to minus 900. Now, minus 900, what does it mean? Okay, minus 900 means the direction of the moment is in fact 900 pounds, right, coming down this way. Because positive is in the what? Clockwise direction, anti-clockwise direction. Negative is in the what? Clockwise direction. Okay. So from here, we know that we are going to see a moment in the y in this direction. Okay. Then from here, we know that the head of the moment vector is in compression. The tail end is in what? Tensor. So easy to remember, right? Or not? If you assemble all together, plus or minus, plus or minus. Yeah, you go crazy. Not just you go crazy, I'll go crazy also. Okay. So from here, we know due to the moment about y, element H, element K is going to be negative, right? Element K is going to be equal to negative. It's going to be compression due to moment about y, yes. And then element H is equal to 0 because it's at the neutral axis. Okay. Okay, there is something very important where students are confused. Even I was confused when I started doing it. Okay, what is the confusion? When we take moment in the z direction, right? When we take moment in the z direction, the moment is the distance from the force to the moment is to the what? Centroid. Yes or no? All right. When we do moment over here, we take it to the element. Can you see that? I repeat again. The one before, right? The 500, there's the 150 that's highlighted. The moment is towards the what? The centroid. Okay. When the moment is about the y-axis, for this case, is towards the what? Element. Right? Then we ask, when do we take it towards the element? When do we take it towards the what? The centroid. right? So if you look over here, right, you say, Eugene, why don't we take element H? This is the perpendicular distance. Yes or no? Right? Where's element K? Yeah, element K I can